All right, so let's look at problem number 4 in chapter 12. It says if you invest $0, and again, that's usually principal. And if you say principal, you don't really need to put a 0 because that means how much you have at time 0. The principal is what you put into the bank, but whatever. So $0 is 7% annual interest, and the future value is computed by continuous compounding. How long will it take for your money to double? So, talked about this before. And it's good to go over again. If you have a continuous growth rate, then that's the E formula. And you have that the amount of money you have, well, I'll call it A. The amount of money you have, A, is the principal times E to the RT, where that's the interest rate. And A or P is the principal. They call it P0, whatever. So I'll call it P0 here. Okay, so the amount of money you have is P0 e to the RT, where the interest rate here, if it's continuous, is 7%. So we have that the amount of money you have is P0 e to the 0.07t. Always remember to change the rate in percent to a decimal. Right, you don't do math with percents. They're good to think about, but yeah, so change that to decimal. So 0.07t. All right, now how long will it take for your money to double? The double means we have 2 times P0, right? We have twice what we put in. So you always just put in 2 P0 then is what the amount of money you have, e to the 0.07t. Divide both sides by P0. The P0s are obviously going to cancel. And we have a 2 is equal to e to the 0.07t. Now notice if we'd wanted tripling time, we would have a 3 there because it's just how much more money we have than what we started. If we want quadrupling time, we'd have a 4 there. So that number there is just the amount of time it takes to do whatever you want, to triple, to quadruple. We want double, so we'll put a 2 there. So we want to get t, we want the time. To do that, to get a t out of the exponent, you always take the natural log, or any log, we take the log. I always like using natural log. Natural log you want to use here because ln cancels out the e. ln and e are inverse functions, they cancel each other out. So take the natural log of both sides. ln of 2 equals ln of e to the 0.07t. Again, ln and e cancel, so that's just equal to 0.07t. Divide both sides by 0.07. So the doubling time is the natural log of 2 divided by 0.07. If we wanted tripling time, it'd be the natural log of 3 divided by 0.07. So basically our formula is the time it takes to double, triple, whatever, is the natural log of the doubling, tripling time. Like here it's double time. So whether you want to double, triple, quadruple, etc., divided by the rate, 0.07. If we want it in percent, you just multiply by 100. 100 times the natural log of that divided by the percent. Okay, ln of 2, like I mentioned in class, is 0.693. So this here is, so I'll erase that. So ln of 2 is 0.693. So that's 0.693 divided by 0.07. And again, if we wanted percent, it'd be 69.3 divided by the rate in percent, and which is about 70. So that's what part C says. It's about 70 because change that to percent, 69.3, rounds off to around 70. Divided by the interest rate in percent, and that's the doubling time. It's pretty cool. If you want tripling time, you take the natural log of 3 divided by the interest rate. Okay, so here they ask how long that takes, so might as well figure it out. So 0.693, or if you want the exact answer, plug in the natural log. It's actually 0.693,147. The next number is a 1, which means that 693 is a pretty good approximation, right? The next decimal is pretty small. But I'll keep it all divided by 0.07. It's about 9.9 years. So we're dealing with years here because it's annual interest rate, so that means per year, so our numbers will always be in years. So about 9.9 years. And again, you could go 70 divided by, if we had done 70 divided by 7, it'd be about 10 years. 9.9 is pretty close to 10 years, right? Good enough. Approximately 10 years. Okay, now the next one is, if you want the value of the account to double in 2 years, what's the required interest rate? We want it to double in 2 years. we want this time to be 2. So now we can just use this formula. So for part B, we know that t is equal to the natural log of 2 divided by the rate. The doubling the time it takes is the natural log 2 divided by the rate. If we want the rate, switch those, right? If one's in the top, one's in the bottom, a nice simple equation like that, you just can switch them. So we have the rate then is the natural log of 2 divided by the time. They say we want 2 years. We want to double in 2 years. What's our interest rate? So that would be the natural log of 2 divided by 2. That's 0.693 divided by 2. 70 divided by 2, about 0.35 or something. So, but I'll do it perfectly. So 2 divided by 2, 0.34657, 0.34657. So that would be 0.34657. That would have to be our rate, or if it's in percent, that would be about, right, 34.6. I hate that. All these numbers are big. So let's say, now that rounds up, 34.7%. So if you want your money to double every 2 years, and growth rate, continuous interest rate of about 35%, roughly 35%, and you'll have double your money every 2 years. If you can get that, go for it. That would be a good deal. Now, if we want tripling, it'd be ln of 3. That's how long it takes to triple. If we want quadruple, it'd be ln of 4. As long as it's continuous growth rate, we can use those formulas, which is really nice. Makes it real easy. So again, the one to remember is, like they say in part C, ln of 2 is about 0.7, 0.69, about 0.7. And if you use percents, multiply by 100, that's 70. So 70 divided by the growth rate in percent, right? So that's approximately 70 divided by the rate in percent. Yeah. All right, cool. Yeah, good. Thanks for listening.